So this video is going to go through questions 1 to 5 on the walk and talk exam that we did in class. So question 1 is simplifying a ratio. First thing to spot with this one is that this one here is in centimetres and this one here is in metres. So you can't have different units in a ratio. So the first thing is to make those the same. So I know that there's 100 centimetres in a metre. So instead of 5 metres, I'm actually going to say that that is the same thing as 500 centimetres. So my ratio would now be 2 to 500 because they're now in the same units. And I want it in the form 1 to n. So I want this number here to be 1 rather than 2. So that means I need to divide that by 2, which means I've also got to divide this by 2 to get 250. So therefore n is just the number here, it is just 250. Right, part B is sharing in a ratio. So the first thing you need to do is add up the numbers in the ratio. So 5 plus 2 plus 1 is 8. So if I do 7,200 divided by 8 to work out what one part of the money would be, so that would be £900. We've got to work out how much Harry received. So Harry is the third name mentioned, so therefore it's the third number in the ratio. So he's going to have 5 parts of the money. So if one part is 900, we just need to times that by 5, and so Harry would have 4,500. Right, question 2. When we're dividing, it's very tempting on this question to just look at the 18, the 6 and the divide symbol and just divide them to get 3. But remember, when we divide, that means we are going to take away the indices. Likewise, if you're timesing, you add the indices. So because it's dividing, we're going to minus the indices. So 18 minus 6 is 12. And we've just got to say the value of k, so the power part. So therefore, the answer should just be 12. I think if you did forget in the exam and you put y to the 12, I think they're still going to give you the mark in all honesty. But just look carefully at the end and just check you have given the right information. So that is questions 1 and 2. Question 3 is writing 120 as a product of its prime factors. So we want two numbers that multiply to get 120. So it could be any two numbers. I'm going to go for 12 and 10. So then you just check, can you split them up even further? Well, 12 I can split up into 6 times 2. 2 is a prime number, I can't split that up anymore, but 6 I can split up into 3 and 2, and they are both prime. Question 10, not question 10, sorry, the number 10 here, you can split up into 5 and 2, and they are both prime as well. So at the end, you've got this dotted line here, so a reminder that you need to write something on this. You don't just leave it in the factorised form like that in the tree. So we've got 1, 2, 3 2's, so it would be 2 to the power of 3. Then we've got 1, 3, so times 3, and then I've just got 1, 5, so times that by 5. So make sure you write it like that, otherwise you drop a mark, and that should be quite an easy 3 marks to get. Right, part 2 is a little bit unusual in the fact that they've given us the LCM, whereas normally we have to work it out. So if we think about how we normally work out the LCM, we normally use the Venn diagram like this. And we know that when we times all the numbers in the Venn diagram together, that gives us the LCM. So we know that the LCM is 360. So if we work out the factorisation of that, so it's going to be 36 times 10. 36 is 6 times 6, and then we can split those into 3 times 2 and 3 times 2. So they are all prime. And 10 can be split into 5 and 2 as well. So that would be, we've got 1, 2, 3 2's, so 2 to the power of 3, 2 3's, and then times a 5. So we know one of the numbers that goes into this Venn diagram is 120, which is what we worked out up here. So basically, if we have a look at that and see what else we would have had to times it by to get to the LCM, and the only thing that we're missing is a 3. This one's got a 3 squared, whereas that one is a 3. So what that would mean is that somewhere in this Venn diagram there must have been an extra 3 compared to the factorisation of this one. So if I make this 120 here, and I'm going to make this the number x that we don't know. So 120, I don't know exactly where these numbers are going to go because some of them may have belonged in the middle. So for now, I'm just going to put them here on the left, like that. And I know that I would have had to times it by an extra 3 to make it this number here. So I'm going to put the extra 3 in like that. But the only thing is with that, if this one had a 3 and that one had a 3, that would have meant actually that 3 would have been shared and it would have gone in the middle, and that doesn't help me now because now I'm back to 1, 3 again. So therefore, because I want to make it 3 squared, I'm going to need to put in another 3 like that. That would mean now that the LCM is 2 times 2 times 2 times 3 times 3 times 5, which is what it is, and that makes then this number here 9 because it is 3 times 3. Right, part B is much more what we're used to doing, so a much kind of fairer question in the exam to come up. So Venn diagram, but this time we're given the factorizations. So I'm going to make this one A and this one B. So looking at what is in both, we've got a 2 to the power 4 here, but only a 2 cubed here. So I can put 3 2's in the middle. I've got a 3 squared here, but only 1 3 there. So I can put 1 3 in the middle. I've got a 5 here, but no 5's there, so no 5's in the middle. And then I've got a 7 squared there and a 7 there. So the most I can put in out of the 7's is just 1 7. So finishing off this circle, I mean I don't really need to actually because it's only the HCF, but it doesn't matter, just for revision's sake, I'm going to finish it off. So if it's 2 to the 4, I've got 3 2's there, I need to put in 1 more. 3 squared, I've already got a 3, I'm just going to put in 1 more. 7 squared, I've already got 1 7, I need 1 more. So to finish off B, 2 cubed I've already got, 3 I've already got, 5 I don't have, 7 I've already got. So the HCF is the middle ones times together, which is why I didn't really need to do that, I just did that more for revision's sake. And the HCF would be 2 times 2 times 2 times 3 times 7. So that is a calculated paper, remember. So 2 times 2 times 2 times 3 times 7. So that is 168. Right, question 4. So if you make sure that you have read this, and you've got to come up with one criticism of Lee's method. So she's asking 12 people to complete the puzzle, and she's trying to find out if there's a relationship between their age and the time it takes them. So the main and probably most obvious criticism of that is that if she's only asking 12 people, it's not really very many. So I would say the main criticism is that she would need to ask more people than 12, or she's only asking 12 people, so that's not going to be a very good sample. I would say that really that is probably the main thing. There's other factors, like some people may have more experience making puzzles, so they might just be better at it because they've practiced more and not necessarily related to their age at all. So any comment that kind of makes sense, I'm sure, is only 1 mark, I'm sure it would get the mark. Right, the scatter diagram. Just remember with these questions that you quite often get a table like this and you have to plot these results onto the scatter diagram, and this is an easy 2 marks to pick up here, but it's very easy to also miss that and just think the question is this bit. So look out for that because you don't really want to lose those marks. So the first one is the age is 47 and the time is 21. So that means you have to go to 47 along the age axis and then up to 21 on the time. So 47 is here, and then I'm going up to 21, which would be here, and you just put a cross. Obviously with a felt tip it's not particularly accurate, yours will be better with a pencil. The next one is 60 and 34, so I'm going to go across to 60, then up to 34, so that's 30 there, so it's going to be 1 2 3 4, so 34 would be there. What type of correlation is shown in the scatter diagram? So correlations, you've got 3 options really. You've got positive, that goes up that way, you've got negative that comes down this way, and then you've got no correlation where they just look all over the place like that. So if they are going this way, it is positive, this way negative, this one you would just say no correlation. So our points are clearly going up that way, so therefore I would describe this as a positive correlation. But the next part is related to the same question. So let me just get that ready. Here we go. So estimating the time it would take a person aged 35 to complete the puzzle. So what I would do here is on your scatter diagram, before you start doing any predictions, is to draw in what they call a line of best fit. So a line of best fit should be roughly like in the middle of the points and going up in the same direction that the points are. So they do say, as a rough guide, you should have about the same number of points below and above the line, but don't spend ages in your exam counting them all. It's just a rough idea. I'm just going to pause the video while I draw mine. Okay, so this is my line of best fit. On reflection, I think it should have probably been just a little lower actually, but I've done it in pen now, so I can't change it. The main thing to remember with this is that they will mark it according to your line of best fit. So obviously your line of best fit has to be pretty reasonable. You can't just draw a line going up here and then use that. It does need to be a sensible line of best fit. And then your other mark is going to be to use it accurately. So we know that the person is age 35, so you need to go to 35 on your age axis, go up like that, and then read it off over here. So on my one, it looks like they are about 11. Oh, sorry, not 11. The time is 11 because I'm reading it on the time axis. So it looks like they would take 11 seconds to complete the puzzle. That's pretty quick, isn't it? So 11 seconds to complete the puzzle. As long as your answer is somewhere around 11, so I would say as a guess, I haven't got the mark scheme in front of me, but probably something like 8 to, I don't know, 15, something like that, 8 to 14, something like that. I'm sure that would be fine. Right, the next one is Lee says that at least 80% of the 12 people completed the puzzle in under 30 seconds. So is he correct? Or she, it's a she, isn't it? So if we have a look at the scatter diagram, we're looking for how many are under 30. So if I just put the ruler here on the 30 line, so the bottom of the ruler is on 30, and we're just counting how many are below 30. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 points that are below 30. So even, you can see again, this is 3 marks, isn't it? So I don't want to just write nothing. So even if you just wrote 9 less than 30, that's 9 out of 12 people. So 9 out of 12. We've got to work out what that is as a percentage. So I would do 9 divided by 12 and then just times that by 100, and it should be then 75%. So is that at least 80? No. Lee is incorrect because 75% is less than 80. And the last question then for this video, obviously this is only question 5, so there will be 3 more videos that you need to watch. So the last question for this video is to do with average speed. So I know that speed is distance divided by time. So the average speed is going to be the distance travelled divided by the time. So the main thing here is to work out the distance. Now I can see on here, when I measure the distance between P and Q, it is 11.4 centimetres. So using that scale here, every centimetre represents 125 kilometres. So I'm going to times that by 125, and I get 1,425 kilometres. So that is the distance travelled. But the time, when we did this before with a Year 11 class, the biggest thing they did, and I think I did mention this once before with you, that they did 1207 on their calculator, just typed in 12.07 minus 9.47. But remember, hours are out of 60, not 100, so you can't just put in time like that on a calculator. So what I would do actually is a number line. I mean, you don't have to do it this way, but I think this is probably the easiest way to work out the time difference. So to make that up to 10 o'clock, you would need to add 13 minutes to make it up to the 60, which then obviously changes it to 10 o'clock. So that's minutes. And then to get from 10 o'clock to 12:07 is 2 hours and 7 minutes. So if I add that together to get my total time, that is 2 hours and 20 minutes. Now again, what you cannot do is say, oh right, it's 2.2, because again it's 20 minutes out of 60, which is actually a third. So if you were going to do it as a decimal, which I probably wouldn't advise anyway, but if you were, it would actually be 2.3 recurring, because 20 minutes is a third of 60. What I would do is change this into minutes. So that's going to be 120 minutes plus the 20 there is 140. So if we work out the speed in terms of kilometers per minute, and then we will change it into hours after that. So I would do 1,425, which is the distance, divided by the time, which was 140. So if I do that, I get an answer of 10.178, where am I? 1785, 7143. That's going to be kilometers per minute. There's 60 minutes in an hour, so I'm just going to times that answer by 60. And then I get an answer of 610.71. So check the question. Does it say how to round it? Nope. So 610.71. But you can see how I have written all those workings down. I'm not just typing things in on the calculator and then just literally writing 610.71. If you made a mistake anywhere along here and all you had written was this and there was something wrong with it, that is 5 marks gone. So please make sure you are writing down every step of your workings. Give one reason why your answer may be inaccurate. So the main thing, there's a couple of things, well, there's quite a few things, but the main two things, obvious things to say, are it's a bit unusual that a plane would go directly from P to Q in a perfect straight line. Quite often they curve around it, and then come in. So I would say that's the first thing. It's unlikely they would have travelled in that straight line. So that's one thing. The other thing that you could say is that there could be a mistake if you measured it incorrectly, so just down to human error in how you've worked that out. Those are the most obvious things I would have thought. Okay, make sure you watch the next video for the next question.